Hello, and today we are doing problem 9.4. This is about determining the structure from these IUPAC namings and some tips and tricks to follow when we want to draw structures from these names is number one, identify your parent chain. So your parent chain is going to be obviously the longest chain, and if we look at, for example, A, we can see that oct is going to be our longest chain. That means that also because it's an octan and not en, we know that it's going to be a straight chain alkane. It's going to be fully saturated. If you look at the other problems in B, we see that hept, meaning 7 carbons, is going to be our longest chain. Here we have a cyclohexane, so that means that we're going to have a cyclical structure. And down here, we also have the same. So now, if you want to tackle problem number 1, so let's draw our 8-chain carbon. So I'm drawing stick notation. I just did one line, but this represents 2 carbons, 1 and 2. And then I continue, 3, 4, 5, 6, 7, 8. And now we know that we need to add the substituents to this parent chain such that it creates the lowest possible number of for the naming. So if we see that we have 4 and 7, this means that if I count 1, 2, 3, 4, on carbon 4, we have a substituent. And also on carbon 7, we have 2 substituents. So let's first begin with carbon number 4. If you look at the very end, the suffix ol, so this suffix represents it's going to be an alcohol. So if I count 1, 2, 3, 4, on carbon 4, we have an alcohol substituent. Now, if I continue, 5, 6, 7. 7, we have 2 substituents, and specifically, we have dimethyl. So we have 2 methyl groups. So we have 1, 2. And this gives us our final structure for this following name. So now let's use the same logic for question B. So hept, that means 7 carbons. Remember, I'm going to start by drawing one line, but that represents 2 carbons. So I'm going to say 1, 2, 3, 4, 5, 6, 7. And now if I see the lowest number is 3, what is at the third carbon? The suffix tells me it's ol, which means alcohol. So 1, 2, 3. And that's going to be our alcohol functional group. Carbon number 4, we have a propyl group. So propyl means pro is the Latin prefix for 3. So on carbon 4, we have a 3 carbon substituent. So 1, 2, 3. And then on carbon 5, we have 1 methyl. And that's how we do this problem. For this one, we see that the parent chain is a cyclohexane. So let's draw our parent chain. And we see that the end of this cyclohexane is an ol, but there's no numbers associated with ol. So we actually get to choose wherever we want to put this alcohol group. That is arbitrarily going to be carbon number 1. So if I arbitrarily choose this carbon, that is going to be carbon number 1. And now I can choose if I want to count clockwise or counterclockwise. For simplistic sakes, I'm going to count clockwise. So this is carbon number 1. Now let's see what's at the second position. As carbon number 2, we have a tert butyl group. So I'm going to draw a T-butyl group, and it's just a cross. And then at carbon number 3, we have a methyl, which is just a stick, as you can draw on here. Obviously, I could have drawn this going counterclockwise, but it represents the same molecule because if you flip it, they would be exactly the same. So the last question, it actually involves something that we haven't been doing for all the previous questions. It involves stereochemistry. Specifically, it says trans 1,2-cyclohexene diol. So let's draw obviously our parent chain. So that's going to be a cyclohexane again. And now we need to extract the other information from this name. So we have a di, which means two, ol, which means alcohol. So we have two alcohols at position 1 and 2, and they're trans from each other. That means that they're going to be on opposite sides from one another. So that means if one of them is facing out of the page, represented by a wedge, the other one must be going into the page, which is represented by dashed lines. So we can draw that. One of these alcohols is going out of the page, and the other one is going into the page. Obviously, we could have drawn it the other way, such that this one will be going into the page, while number 2 will be going out of the page, but whichever method we want to choose, we have to make sure that they're opposite. One is going to be a wedge, meaning coming out of the page towards us. One of them is going to be dashed lines, meaning going into the page away from us. And this represents trans. If the question said cis, then they're both going to be on the same face of the molecule, meaning they're both going to be wedges or both going to be dashes. I hope this helps, and see you guys next time.